Good evening. My name is Chelsea Fountain, and I am doing my welcome to my presentation. In this presentation, I will use a flow chart to provide an integrated outline of an immune response, beginning with entrance of antigen, beginning with the response of an innate immune system to antigens, and the end results for B and T cells. So innate immunity begins there. Sorry, can you just follow along? This is the best technology I have. Okay, so the immune system is the body's defense against infections. The immune response is how the body recognizes and defends itself against bacteria. So you can see here where it says the first defense. So the immune response is how the body recognizes and defends itself against bacteria, viruses, and substances that appear foreign and harmful. Any antigen that comes into the body triggers the immune system response. There are 3 ways the immune system responds to antigens: innate immunity, adaptive immunity, and passive immunity. So I began with innate immunity, which is non-specific, and then we will move forward throughout this presentation. So innate or non-specific immunity is this defense system we are born with. It protects us against all antigens. These defenses are described as non-specific because they do not target any specific pathogen. Rather, they defend against a wide range of potential pathogens, and it provides the first line of defense against invading bacteria. Innate immunity has two types of defenses. You have your first, and then you have your second, as seen on the flow chart. Let me get a little closer. The first line of defense are external barriers such as the skin and mucous membranes. The skin is the biggest body organ with the largest surface area to defend against the outside environment. The skin has an outer layer called the epidermis, which protects the body from harm and produces new skin cells. The second line of defense, as you can see on my flow chart here, are the internal barriers such as protective cells and blood. The cells involved are white cells called leukocytes that help the body fight disease. Innate immune cells not only provide rapid protection against invasion, but also serve as a bridge between microbes and the adaptive immune system made up of T and B cells. Adaptive immunity is specific. Now we are moving to the middle flow chart here of the middle column of the flow chart. So adaptive immunity is specific, and it has a memory, which means it builds up antibodies after repeated exposures to specific antigens. Over time, the immune system builds up a defense against specific antigens. As mentioned earlier and shown on the flow chart, the adaptive immune system is made up of T and B cells. So T and B cells are a type of white blood cells called lymphocytes. B lymphocytes become, I hope I'm pronouncing that correctly, cells that produce antibodies which attach to specific antigens and make it easier for the immune cells to destroy the antigen. T lymphocytes attack antigens directly and help control the immune response. They also release chemicals known as cytokines, which control the entire immune response. The last type of immunity is passive immunity, which is a temporary or short-lived response that is acquired when antibodies are given to a disease rather than being produced through the immune system. Passive immunity can happen naturally, as it does when an infant receives a mother's antibodies. So in conclusion, the immune system is triggered when an antigen is detected. As the flow chart illustrates, the immune responses uses different mechanisms to recognize and destroy substances that contain antigens. This does conclude my presentation. I hope you enjoyed my visual, and thank you for listening.